Okay, we're going to try and solve the pool. And let's just check we've got all the information. So read the question up above, because you'll notice it says angle ABC is 78 degrees. So we'll put that in, angle ABC, so that's that one in there, is 78 degrees. Maybe they couldn't draw it on the diagram, so we'll put it in. Your ABC is divided off by a straight low wall to make a shallow paddling pool for toddlers. How long is the wall if it goes from A to C? So we'll draw on that wall and we'll call it X, because that's what we're going to look for. Now I haven't got a lot of space here, but of course you can be answering this on some paper and you could set your working out so you've got lots of space. Anyway, we need to find this length here. So we're looking for a side. I notice that I've got the angle opposite it and two other sides. This sort of forms that V shape with the angle and the two sides, so that tells us that we're probably going to need a cosine rule. You could try the crisscross of the sine rule. You've got a side and an angle, but unfortunately we don't have any other angles at this stage. So let's use the cosine rule. So finding some space somewhere. X squared equals, using the cosine rule, one of the other sides squared plus another side squared minus 2 times one of the sides times the other side times the cosine. It's not going to write off the page, so we want to go times the cosine of 78. This will give us a value for x squared, and we'll write down as much as we can. 817 point, there's a whole big long decimal, and you can pause the video and check that on a calculator if you want. Now to find x, we're going to have to square root that, and some of us like to write square root of ounce, and when you do that you end up with 28 point, and there's a big long decimal there. That would be in metres. Right, so I'll go back up and put that on my diagram. Good technique to get into. 28.584, and some other numbers after that. 7, 5, 6. We might include as many as we can so we don't worry about rounding metres. Okay, we've answered part A. And if this was a test, you'd make that stand out and you might write the answer in here again so that people know which answer that's for, but I don't have a lot of space on this screen. Okay, the next question, and you can read it off your sheet, says that Sue thinks of a more interesting way of dividing the pool to make a paddling pool would be to draw an arc of radius 20 metres and centre B. How long would this new wall have to be? So if she's having this is the centre, the word arc makes me think of a curved wall. This is the centre, 20 metres is the length, so it's going to come around like this. Now if it's 20 metres, then it should come down here 20 metres as well. So it will come down and cut somewhere around here. It doesn't matter where on your diagram, as long as you understand that the curved wall is going to come around this way. So what I'm left with, of course, is a sector in here. The radius of 20 metres, even if it doesn't look like it on my diagram, and a curved wall. The question said, how long would this new wall have to be? So we're looking for an arc length, we might call it arc L. There's a formula for that. I'm going to come up and do it over in the corner here because I don't have a lot of room, but you can be doing it on paper. Arc length equals R times theta. Now of course we have to remember that that angle has to be in radians, so looking back at my diagram, that angle is in degrees. So if we just erase that and go back to my pen, over here we might do the change, 78 degrees, and I want to change that to rads. So I'm going to have to times it by pi over 180, or 180 over pi. For radians, we associate pi's with radians, so I want a pi times 180, and hopefully on the calculator, 78 times pi divided by 180, and that of course will be a big long decimal as well, and we get 1.36135, and I'm going to struggle to fit it in, 6817, but hopefully you can fit it in on paper, and that's in radians. So now we can go back over to our arc length formula to find the length of the curved wall. The radius is 20 times the angle in radians, 1.36135, and I'll just use answer on my calculator because I've got that number sitting there, times it by 20 gives me an arc length of 27.227 metres. It's rounded to 3 dp. Now the question did ask how long would this new wall have to be. If we just compare it with the old wall, you'll see that the new wall is actually shorter, and you might like to write a sentence mentioning that this new wall is actually shorter than the old wall, and you could work out the difference between the two as well and let somebody know the difference between the two walls.